Hi, Calculus. So we're just about the end of our revolution of solids. After this, you're going to be looking at integrals. For example, the integral of e to the 2x dx is equal to 1 half e to the 2x plus c. So we're going to get back to those antiderivative pieces. So I know that for some of you this has been fairly challenging, and I get it. We're doing our best with it. Make sure that you watch the 2 videos this week, and then the third one regarding just kind of the review for the test, and the things that we need to do to prepare for next week. Okay, so your test is going to be I guess so. Today's April 9th, but as you're watching this video, it'll be the following week. So make sure you watch videos this week. I'll be explaining exactly what the test will look like, and I'll be able to help you out in that regard. Okay, so let's check out this kind of a problem. We want to look at the curve y equals 3x squared minus x cubed, and we're going to revolve it around the y-axis. And this is going to bring up kind of our third option for volume. So we've done discs, we've done washers, and this is another one, okay? And I don't want to look at this section right here of the curve. I'm going to look at this section right here of the curve, okay? And I'm going to revolve it around here, okay? So it's going to revolve like this. And so your first thought is to be able to set up washers. And if you're drawing this, don't draw this right now because washers doesn't work. I'm going to show you why. As you make a horizontal revolution, you can see that in this situation, you end up with you end up with that washer right there. And with that washer, you set up pi times big R squared minus little r squared. And if you notice, what makes the outer radius? The outmost radius is made up of by 3x squared minus x cubed. And this inside radius is made up of also by 3x squared minus x cubed. So if the outside and the inside are the same, when you subtract them, they're going to completely disappear. And that's a huge issue. And so washers doesn't work. And a lot of people fight this method when they see it. I want to encourage you that this method works out really, really, really well. It just takes a little bit of time to grasp it. And once you do, it's super slick. In fact, I often use it instead of washers because it's so easy. We're going to take that same shape. Yes, we're going to revolve it. But here's what I'm going to revolve. I'm going to grab a rectangle. And as I grab that rectangle, that's at some x value. It has a width of dx. As I grab that, I'm going to rotate that thing around. And when I rotate that thing around, I get this cylindrical shell. So I actually have something right here. Imagine that this thing has a hole all the way through it. It doesn't, it's kind of like a pencil holder, so I guess it doesn't work real well. But imagine a hole all the way through. This is the thing that you would be getting. Okay, it's thin on the outside. It's like a shell. You think of like a bullet casing. It just got the shell on the outside. Then the fact is that we can find the volume of that shell. And these shells just keep on stacking. If you would have drawn it here, watch what happens. Then you get, the shape over here. You get another shell that stacks there. And if you did one here, you get another shell. Another shell. They just continue. So picture this guy sitting in another piece, almost like Tupperware that stacks inside of each other. Some people think of them, I think they call them like Ukrainian Christmas dolls, where you like open one and there's one on the inside, you open up another, there's another on the inside, and you keep opening them up, but there's just a ton of them sitting inside on top of each other. That's what happens with these infinite number of shells. They stack and stack and stack and stack. So that's the idea behind a shell. It's like this guy. Hopefully I've made that clear. If you need more help with it, you can watch one of my videos from previous years on cylindrical shells. It might look better if I use the smart board, or you can just research online and look up cylindrical shells calculus, and you might get some really good pictures. I'm a little bit limited to what I can draw here. But let's get to the point of how we actually find the volume of just one of these shells. I'm going to take that region. That's, again, y equals 3x squared minus x cubed. I'm going to slice a rectangle. That's at an x value. Some x value sits between 0 and this spot here is 3. This is some x value. And it has width of dx. I'm going to revolve that around. As I do, I get a cylindrical shell. How do we find the volume of that shell? What we do is we unravel it. So kind of like a label on a soup can. We just need to find the volume of that thing, and that's not that difficult. Notice that it's a rectangle with width. The width is dx. It has certain height. What's the height? The function. 3x squared minus x cubed. And then we just need that length. Well, the length of that label is the same as circumference. Circumference is 2 pi times your radius. And in this situation, look at the radius. The radius is the distance from whatever x value you choose, something between 0 and 3, some x value, and 0. What's the distance between x and 0? The distance is just x. So in this case, the radius is just x. It often ends up being x, and it makes it super easy to do our integration. The volume of this piece is 2 pi times x times 3x squared minus x cubed dx. That's the volume of one of those things. We want to do an infinite number. So we slap on an integral, and we integrate from 0 to 3. Working through the integration piece is nice and simple. I know that you guys know how to do this now. The setup is the part that's challenging. Let's work through the integration though. 2 pi times the integral from 0 to 3 of 3x cubed minus x to the 4th dx. I distribute that x through, and I get 2 pi times antiderivative of 3x cubed is 3x to the 4th over 4. Antiderivative of x to the 4th is x to the 5th over 5. We're going to plug in 3, and we're going to plug in 0. As I plug in 3, 3 to the 4th is 81 times 3 is 243 over 4. Plug in 3, 3 to the 5th is 243. In this case, it's over 5.